it's by using matrices. Matrix is basically a, what should you say, rows and columns of numbers like this. This is a matrix. And matrices, you can, those numbers in matrices, you could multiply and add matrices together and do a lot of tricks with matrices. It's a mathematics of its own, but the key point is here, you could use matrices to describe exactly the same thing in between here. So if you believe it's a wave, because we're using a mathematical description that talks about waves, then you believe is based on a mathematical tool to describe what happens in between these events. What I'm telling you is there is another tool you can use. You could use matrices to describe the very same thing, and it doesn't involve any waves. It's just matrices. So now my question is, and if you believe it's a wave, why do you believe it's a wave? Because somebody says it's a wave. Why did they say it's a wave? Well, they say it because they're using wave mechanics to describe this. If you believe it's a wave, then I'm justified to believe it's a matrix, because I could use a matrix mechanics to describe the very same thing. You get my point here? My point is, we don't know what's happening in between here. What we know is we can use different mathematical tools to explain, no, not explain, make up a story what happens in between these things. Because like here, the story here is we assume a persistence of existence, and then we make up a story because we didn't observe. This thing was never observed. We made up a story and said that there is something here which is that very same thing. Do you understand what I'm saying? When I say persistence of existence, that is, this thing here was moving over here in order to come here. It has a persistent existence all the way around here. But in quantum mechanics, the only thing we know is something happened here, and then a little bit time later, something happened here. What happened in between, if we think about it as a particle, then we have a lot of problems. So all this leads us to the following thing, is that what we observe here is not a particle, we're observing an event, which was what I said before. These, in quantum mechanics, we observe events, and those events, I said, are positions. So we observe an event here at one position, and we observe an event here at another position. This is event-driven explanation. And then what happens in between, we have no clue. But we knew we could make up a story that drops this assumption of persistent existence, and that story tells how these things emerge here. That's what that story is telling. But the thing here is, like, okay, so we have one story here talking about waves. So then we could ask ourselves, is there a wave here? Or more precisely, is there a field of some sort, a wave, which goes over here? and then hits here and makes this interference pattern. And it's very easy to answer that, because if you send, no, it's not easy to answer that. But there is an interpretation that it's an interpretation of it that makes it easy to answer it. If we assume this is a particle that travels over here and then somehow bounces off here and do a lot of things and creates these interference things, then the answer is, I had a break there because I lost my thought. So then the answer is that if it's a particle, if you interpret this as a particle when it comes from the source and a particle when it hits the source, then the answer is it doesn't make any sense, the wave description anymore. Like how is a particle a wave? It doesn't make any sense. And since we haven't observed it in between these two elements, we can't say it's a wave. The only thing we could say is it behaves like a wave. That's the only thing we could say. But what it is, we can't say, because if it's a particle, is it then a wave afterwards? How do we know if it's a wave? Well, we could know that by trying to observe that wave. And one way to observe if it's a wave is to try to detect that wave when it passes the slits. However, it turns out if you try to do that, then the interference pattern disappears. Right? So, I'm not going to go into the philosophical meanings or possible interpretation of this. The only thing I'm going to say is like we're back to square zero and basically asking ourselves, what the hell happened here? There apparently we now have this here, this observation here, and that observation says it did either pass A or B. That what that observation in between tells us. It either passed here, it passed A, or it passed B, but not both. Or not none. It passed one of the slits, but not both. That's what that observation said. And when we do that observation, we don't get the wave interference patterns anymore. So then the question is, so, well, if it only passed one slit, then it's not a wave, right? So you could say that, okay, something is wrong with the wave interpretation. Or you could say that if you try to interpret it, then you run into incoherent stories. And this is what I want to come to in quantum mechanics. You can't make that assumption that it goes in a straight path. You can't make that assumption that it goes in this path or that path or both paths at the same times. And this is what the Copenhagen interpretation comes back to when they say don't interpret the mathematics. It says like don't interpret that wave stuff because it's something that is not observed. It's in between observation. And if you try to observe that wave, the wave goes away. So what the quantum, the Copenhagen interpretation of the quantum mechanics says is like, don't try to interpret it. And the second point I want to make here is like and then you could still believe, yeah, it's a wave, you know, even if we can't interpret it, maybe it's still a wave, you know, because after all, it has wave behaviors. I just told you there is a second tool, matrices, you could use to describe the very same thing. Does that mean if I use this method, it suddenly become matrices that's is in between here? No, it doesn't mean it. It just means it's a mathematical tool, it's a narrative to create a story for us to be able to predict where the particle ends up. And the thing is, both the wave theory and the matrix theory accounts for the in-flight observation, if we call it so, the observation here in the street. It encounts for that situation, and it encounts for the situation where we only do 2 observations. But the mathematics is still talking about what's happening in between here. And if we try, and I just told you, if we try to validate that story about what's happening in between by making an observation, then that story, that narrative goes out the window. And we have to make up another narrative to explain it. And the problem is such in quantum mechanics that now you don't have one thing to explain, but now you have to explain this thing here as well. And what the story says is like, okay, it's an event here, an event here, an event here, and position, position, position. And in between here, we could use waves or matrices to describe this, and waves or matrices to describe this. And if we try to go in between here and observe there, then we comes back to the same problem again. That in that observation there, that wave description goes out the window again. But in between there, we still have the wave description. And my point is, there is never a wave description when you observe an event. Never. The wave description is only in between non-observed things. And when we try to validate that wave description, it goes out of the window. That is to say that if we do like pre-20th century thinking about matter, that there is a persistence of existence, that we can like assume a straight path here for good reasons, this doesn't hold true anymore. You can't make that assumption anymore. So basically, let's see if I have more time.